And then we have our vertical part. So this is our beam. Okay, so this is our, and at the same time, I want us to sketch the transformation relative to the 3D view. That is this is important. Okay, so how our transformation looks like. So we know that over here in this orientation, this is our Y orientation. This is our Z, and over here this is our X. And buckling can occur in two planes. Okay, buckling can occur in two planes, and the two planes that it can occur are these two planes. Okay, so one plane it can occur. Oh, I beg your pardon. So one plane it can occur. It can occur about this plane. So this plane is known as our XY plane, or we call it buckling about our ZZ axis. You can call it either way, it's fine. Okay, and then another plane that it could buckle is it could buckle about this plane, and this plane we call it our XZ plane, and we also call it buckling about the YY axis. Okay, so I'm going to now sketch for you. Okay, and we're going to look at two different views of how this will buckle. Okay, so the first view that we are going to sketch, I'm going to sketch the XZ plane first. Okay, XZ plane. So on the XZ plane, this is my X axis. This is my Z. And we know that this is our rotation in the Y. Okay. So when we sketch this out, so XZ plane, so the structure looks like this. Okay, so I'm gonna use a different. Okay, and then we have our geometric centroid. And because it's an I-beam, right, we are going to see some hidden detail. This is the web. Yeah, this is the web. Okay. So when buckling occur, I'm going to draw the deformation pattern. Okay. The buckling will deform this way. Okay. And I'm going to draw the rotation about Y. So rotation about Y, I want you all to watch the curvature. So this is rotation about y, right? That's the rotational direction. So by looking at the rotational direction, okay, by looking at the rotational direction, and by looking at the deformation pattern, right, they are in the same curvature. Okay, the orientation of the curvature is the same. So we can also address this as buckling. Okay, we can also address this as buckling about the YY axis, right? Why is it YY? Because it follows the curvature, right? About rotation about Y, okay? And when that is the case, the critical load about the exact plane is equal to pi squared EI. Now, I about y-axis, I about the y-axis, or we can just call it y-axis, divide by LE squared. Okay. So this is in terms of IY, right? As you all can see that. Okay. So that's why we call it, once you know that buckling is about the y-axis, we are going to use IY. If you look at the bending moment, right? Remember we have the bending moment formula where stress X or stress X will be equal. So let me see, is it called? Yeah, stress X. If the moment is about Y, right? You use what? IYY multiplied by Z. Yes or no? Right? In terms of, this is in terms of bending moment. And if you look at the structure, how it is deformed in terms of moment, we also have moment, right? Acting about the what? Y-axis. So these are the similarities regarding bending, okay, and buckling, as you can see now. Yes or no, right? So now the next one that I want to highlight now, okay, are we clear? If you all have questions, you all can just stop me and say, Eugene, or type something, tell me, Eugene, can you repeat that? Okay, if not, I will still proceed. Okay. So far, I don't hear anything. So far, I'm going to assume so good. Okay. Now, the next one we are going to look at is the other orientation. Okay. So now we are going to deal with XY plane. Okay. So now we are going to deal with XY plane. Oh, before I go on, I like to highlight this, that the load over here, this is still P in the X direction. Okay, can you include that, please? Okay. So next we are going to look at YZ plane, XY plane. So XY plane, how it looks, it looks something like this now. Okay. Oh, let me change color. And then I'm going to sketch the thickness of the web, so thickness of the flange. Okay. You got no hidden details over there or hidden features. Right? And then we have our geometric centroid. Okay. Then we still have our P. Now P is still in the X direction. So now we are, if I draw our transformation, this is now our X. And now this is our Y. And then we have our rotation in the Z. Okay. So the next thing I'm going to do, like before, I'm going to sketch the deformation pattern. Okay, so that is our deformation pattern. And if you look at the curvature, right, the one I'm highlighting is we have the same curvature as our rotation in the Z. So we call this, likewise, we also address this buckling about now is the ZZ axis. Okay. And then when we calculate this, right, so PCR will then be in the XY orientation. So this is equal to pi squared E IZ, right, over LE squared. You see the difference now. Okay. So in a nutshell, okay, you to do this properly, okay, you need to sketch this out, okay, and see where and look at two different planes and sketch the deformation pattern, and then you're not so confused whether which one should I use, IYY or IZZ. Okay, so this is so much easier. Okay, so much easier, right? So the next thing that a lot of times students get confused, right, is the second moment of area, right? And I'm going to help you guys out in this. Okay, so we are going to look at how to calculate IYY or IY and IZ. Okay, how to determine IY and IZ. And a lot of times it can be really confused. And I'll write out the general formula first. Okay, I'll write out the general formula. So the general formula is if we were to look at IY, this will be equal to width multiplied by depth cube over 12 plus by width multiplied by depth multiplied by capital Z bar minus by small z bar and the whole thing squared. Okay. And if I were to write what is our IZZ, or it can be called IZ, this is also equal to width depth cube over 12 plus by width and depth, okay, capital Y bar minus small y bar and the whole thing Z, where the Y capital Y bar and Z bar is the global, is the position of the entire section centroid, where small y bar and small z bar represent the position of the individual section centroid. Okay, so there's a big difference. One is the entire section, one is the individual section. Okay, now, so let's look at, so I'm going to, not enough space over here. I'm going to bring it over to the next page. We're going to do side by side so you can compare, contrast the difference. Okay, so on the left hand side, we are going to determine IYY. Okay, and the right hand side later on we determine IZZ. So we know our axis. Okay, we know our transformation. So this